Yeah, hello everyone. Disha Kansara here, and my SAP ID is 6000119800 and today I'm going to explain the first experiment, which is inverting and non-inverting amplifier using op-amp in LT Spice. So first of all, I like to explain the inverting amplifier. So this is my circuit of inverting amplifier where I input is given to the inverting terminal and non-inverting terminal is grounded. So here the is an inverting amplifier circuit. The operational amplifier inverting input is receives the feedback from the output of the amplifier, assuming the op-amp is ideal, and applying the concept of virtual short at the input terminal of op-amp. So the voltage at the inverting terminal is equal to the non-inverting terminal. The non-inverting input of the operational amplifier is connected to the ground, and the gain of the op-amp itself is very high, and the output of the amplifier is matter of only a few volts. This means that the difference between the two input is accidentally small and can be ignored, as the non-inverting input of the op-amp is held at the ground potential. This means that the inverting input must be virtually at the earth potential. So this is my inverting amplifier. So the output equation of the inverting amplifier is minus RF by R1 into V1 or Vin, and the gain of the op-amp is minus RF by R1. So this is my inverting amplifier, and second one is non-inverting amplifier using op-amp. So in non-inverting amplifier, the input is given to the non-inverting terminal and inverting terminal is grounded, and the non-inverting amplifier is the one in which the output is in phase with respect to the input. So the feedback is applied at the inverting input, and however the input is now applied the non-inverting input, the output is non-inverted, which in terms of phase, which amplified a version of the input. The gain of non-inverting amplifier circuit of the op-amp is easy to determine, and the calculation hangs the around the fact that the voltage at the both inputs is same, and this arises from the fact that in gain of the amplifier is existing high, and if the output of the circuit remains within the supply rails of the amplifier, then the output voltage divided by the gain means that there is a virtual no differences between the two inputs. So this is the short introduction of the non-inverting amplifier using op-amp, and the output equation of the non-inverting amplifier is 1 plus RF by R1 into Vin, and the gain is AVF is equal to 1 plus RF by R1. So this is my non-inverting amplifier. So now first of all I'm plot the schematic of the inverting amplifier. So I start LT Spice, and in a file, first of all I take a file menu, new schematic, and here I'm plotting the inverting amplifier first. To select any component, I select a component and click OP07. I take it first. Now I select the resistors. Here is my second resistor. So yeah, and I now connect the voltage source. I connect to the inverting terminal, and given the voltage source plus and minus 15 volts here, connect with the wire with all the resistors. Now I'm connecting the voltage source to the ground, and here I'm giving a common ground to the voltage source and connect with the wire. Yeah, so I'm done with my connections. Yeah, here I also connect the VCC and VEE. Yeah, so I'm done with connections. So first of all, I labeled the name or VCC. Yeah, so I'm giving the name first of all. This is my V out. This is my VEE. This is also VEE. And this is I'm going to label VE. Yeah. To move any component or name, I use this move. So yeah, I labeled all the name. Here I'm labeling the RF register, and this is my R1. Yeah, I'm now giving the value. For this, I click on advanced and I giving a sine wave. Here I'm giving a 0 DC offset. My amplitude I'm now giving a 2 volt, and my frequency is 1K. Yeah. So now I'm going to give the value of resistors, which is 1K. this is my 2K. I'm going to explain this circuit for gain 2. Here is my 15 volt plus 15 volt, and here is my minus 15 volt. Yeah, so my circuit is ready now. I'm going to simulate, click on run, and my stop time is, let's say, 3 milliseconds. Okay. Yeah, so in this I check the input and output wave. So yeah, this is my yeah, so this is my input and output waveform. Yeah, in a green wave, this is my input wave, and in a blue, it is my output wave, where I given the 2 volt peak to peak, which is an input, and I get the output of 4 volts. So yeah, this is my output of the input of 2 volts and gain of 2. So now if I change my gain for let's say 5, and if I applied the my input as a 5 volts, so let's see the output. Yeah, so I get the output in a saturation. So if I applied the 5 volts in a input, so I get approx the 14 volts. Yeah, the 14 volts in a output, where the this positive saturation is called the plus Vset, and the negative saturation is called the minus Vset. So I got the saturation as an output. Yeah, so this is my inverting amplifier. I already made the non-inverting amplifier. Yeah, so this is my output for gain 2. Yeah, this is my circuit for the non-inverting terminal. So here I give the input to the non-inverting terminal, and my inverting terminal is grounded. Here I give the 2 volts input and gain of 1 kilo for the gain of 2. So I get the output here, where I 2 volts for where I get input of 2 volts and I get the output of 4 volts. This is for the gain of 2. This is for the gain of 3 of non-inverting terminal, where I give the RF2K for the gain of 3, and I give the sine wave and 2 volts input, where I get the output of the 6 volts. And for the saturation, this is my circuit of non-inverting terminal, and I get the saturation for the non-inverting, where I get the output of approx 14 volts. Yeah, so this is my circuit of inverting and non-inverting amplifier, where I theoretically and practically get the waveform. So yeah, thank you.